In this video, we are going to be discussing different techniques to solve exponential equations. In all of these equations that we solve, we're going to start off by asking ourselves the same question initially, which is, can we get the same base in the exponential equation? Depending on the answer to that question will determine what technique we use to solve the exponential equation. So starting example 1, we have 5 raised to the 3x minus 1 is equal to 125, and we ask ourselves, can we get the same base? So between the bases of 5 and 125, can I rewrite one or both of those numbers so that I see the same base? And the answer is yes. We can use a base of 5. So the left side of the equation already has a base of 5. So I'm not going to change anything there. But on the right side of the equation, instead of writing 125, I'm going to instead write 5 to the third power, because 5 to the third power is 125, and now we have the same base. And the reason that that's important is because the one-to-one property for exponentials says that if you have b to the x equal to b to the y, then you can simply set the exponents equal to each other. So in other words, if 5 to this power is equal to 5 to that power, then this exponent of 3x minus 1 must be equal to this exponent of 3. And now we can simply solve this linear equation. I'll add 1 to both sides, and then I will divide both sides by 3 to get that x is equal to 4/3. Remember that the domain of an exponential function is all real numbers, so we don't have to worry about any potential domain issues. We start example 2 the same way by asking ourselves if we can rewrite this equation so that we have the same base on both sides. And the answer to this question is again yes. I can rewrite both sides of this equation with a base of 2. Because 1/4 is the same thing as 2 to the negative 2, and 8 is the same thing as 2 cubed, and it still had that exponent of x on it. Rules of exponents tells me that we combine these exponents on the right hand side by multiplying to simply give us 3x in the exponent. Now we're ready to apply the exponential one-to-one property, which tells us that we can simply set our exponents equal to each other. Now we're ready to solve for x by dividing both sides by 3 to give us that x is equal to a negative 2/3. In example 3, we start off the same way. Can we get the same base between 8 and 4? And the answer is yes. We can use a base of 2 because we can rewrite 8 as 2 cubed, and that still has an exponent of x plus 3 on it, and we can rewrite 4 as 2 squared, which still has an exponent of 5 minus 2x on it. Rules of exponents tells us that we combine these exponents by multiplying, so I'll distribute the 3 to give me 3x plus 9 in the exponent on the left side of the equation, and I'll distribute the 2 to give me 10 minus 4x as the exponent on the right side of the equation. Now that we have our equation written with the same base on both sides of the equation, we are ready to come in and apply the exponential one-to-one property that tells us if 2 to the 3x plus 9 is equal to 2 to the 10 minus 4x, then those exponents of 3x plus 9 and 10 minus 4x must be equal to each other. And now we're ready to continue solving this equation to get that x is equal to 1/7. So the first 3 examples that we've seen, the answer to this question has always been yes. So when the answer is yes, that you can get the same base, that's what you do. You do some work to get the same base on both sides of the exponential equation, and then once you have the same base on both sides of the exponential equation, you come in and you apply this exponential one-to-one property that says you simply set the exponents equal to each other and solve. Now we're going to look at some examples when we start that problem, still asking ourselves the same question of can we get the same base in this equation. The answer is now going to be no, because between 2 and 7, I cannot get the same base. So how we approach this problem when we are unable to get the same base is we take a logarithm of both sides. It didn't say which logarithm, it just said a logarithm. So for instance, if I choose to use the logarithm with a base of e, then I'm using the natural logarithm on both sides of this equation. So I would stick the 2x inside the natural log, and I would stick the 7 inside the natural log. I could have also chose to use a base of 10 on the logarithm. So then I would have just had log of 2x is equal to log of 7. And I'm also going to choose to use a base of 2. So these are all 3 different ways we could start solving this problem. This simply said take a logarithm. It didn't say which logarithm. I'm showing what we would get depending on which logarithm we chose to take. So I've started the problem 3 different ways by taking a logarithm on both sides. Let's go back to the first way. If we had used natural log, the whole reason that we want to use a logarithm is because then we want to come in and apply the power property, which tells us that I can bring the exponent of x down in front of my logarithm. And that's true regardless of which log we chose to use. The power rule is true for all logarithms regardless of their base. So in all of these scenarios, the exponent of x will come down in front of the logarithm. Now, to continue solving for x, in the first case we would need to come in and divide both sides of the equation by natural log 2 to give us that x is equal to natural log of 7 divided by natural log of 2. In the second case, we would need to come in and divide both sides of this equation by log 2, which would give us that x is equal to log 7 over log 2. And if we chose to use a base of 2, hopefully now you're seeing why I chose that particular base, because log base 2 of 2 is equal to 1, because 1 is the exponent that goes on 2 to give us 2. So this simply gives us that x is equal to log base 2 of 7, which by definition makes sense, because log base 2 of 7 is the exponent that goes on the base of 2 in order to give us the answer of 7. We start example 5 by asking ourselves the same question. Between 3 and 0.07, can we get the same base? And the answer is no. Because we cannot get the same base, I'm going to take a logarithm on both sides of this equation. I'm going to show 2 different ways you could do this. You may be thinking, oh, I'm going to choose to use log base 3 on both sides of this equation. That's a very good choice, especially considering that the base of the exponential is 3. Well, you also don't have to use log base 3. You could have just used log. That would be fine as well, regardless of which one you choose. Or you could have used natural log. Regardless of which one you choose, I want to show at least both ways, one where you use a log with a base of 3 and one where you do not. So if you use a log with a base of 3, what happens here is this log base 3 and this exponential base of 3 cancel out and simply leave us with negative 0.02x. And then to finish solving for x, we would need to come in and divide both sides of this equation by negative 0.02. And then we're left with this as our answer. If we needed to put this into the calculator, we could use the change of base formula to write the expression that's in the numerator in the calculator. On the other hand, if we chose to use log without a base of 3, just with a base of 10, the power rule still applies here, and this exponent of negative 0.02x comes down in front of log 3, and it's equal to log 0.07 still. And then to solve for x, we would need to divide both sides by not only the negative 0.02, but also the log 3, leaving us with x is equal to log of 0.07 divided by negative 0.02 log 3. And we could put this expression in the calculator to finish getting our answer. We start example 6 by asking ourselves the same question. Can we get the same base in this exponential equation? We can definitely see that we do have e as a base right here. Whenever we have e as a base, we are not going to be able to get the same base, unless all the other bases were already e. So what we're going to do here is we're again going to use a logarithm. Perhaps it would be a best choice to use the natural logarithm, since we do know that the base of the natural log function is e, but the issue is if we come in and we just go ahead and apply the natural log to both sides of this equation, that's not helpful, because then that gives us addition on the inside of this natural log, and we know that there is no rule to simplify addition on the inside of the logarithm. So instead, the first thing we're going to do is we're going to simply isolate that exponential in that equation before we introduce the natural log. So I'll subtract 4 from both sides of this equation, which gives me a 7 on the other side, and then I'm going to go ahead and divide both sides of this equation by 3. To give me that e to the 2x is equal to 7 over 3. And now that I have this exponential nicely isolated, now we can come in and introduce natural log on both sides of this equation. And the reason that we introduce natural log on both sides of the equation is because natural log and the base of e in the exponential will cancel and simply leave us with a 2x on the left side of the equation. And then we can finish solving for x by dividing both sides of this equation by 2 to get that x is equal to natural log of 7/3 divided by 2, which we could put into our calculator and approximate if we needed to. Example 7 is another example where we can't get the same base. Between 2 and 3, we're not going to be able to do that, and so I'm going to come in and start this problem and apply a logarithm to both sides of this equation. I'm going to come in and apply log base 2. We could also apply log base 3 to both sides of this equation. So I'm looking at what the base of these exponentials are to determine which logarithm I want to use, but I want to point out that we don't have to necessarily use log 2 or log base 3. I could also use ln if I wanted to. I could use ln on both sides, or I could just use a plain log if I wanted to on both sides of this equation. And I want to work it out both ways so we can see. So if I had chose to use log base 2, then what happens is this log base 2 and this base of 2 cancel out and simply leave us with 3x minus 2 on the left side of the equation. Nothing cancels out on the right side of the equation, but the power rule can still happen here, meaning we can still bring down this 2x plus 1 in front of this log base 2 of 3. So if we use log base 2, the base of 2 will cancel out in green. If I use natural log here on the right side, nothing's going to cancel out. We're just going to be able to use the power rule on both sides of this equation, giving us 3x minus 2 in front of a natural log of 2 and 2x plus 1 in front of a natural log of 3. Now, in both cases, we have to come in and distribute. There's nothing to distribute right here, but over here we need to distribute the 2x to the log base 2 of 3, and we need to distribute the 1 to the log base 2 of 3. Similarly, on the other side, I'll need to distribute this 3x to this natural log 2, and this 2 to the natural log 2, and on the other side of the equation, the 2x to ln 3 and the 1 to ln 3. Now, at this point, what we need to do is we need to get the terms that have x on the same side of the equation so that we can factor x out. So I'm going to choose to put all my x terms on the left side of the equation. So I'm going to move this 2, and I'm going to move this 2x log base 2 of 3. And that's going to leave me with 3x minus 2x log base 2 of 3 equal to log base 2 of 3 plus 2. On the other side of the equation, on the other side of the page, same thing. I'm going to combine my terms that have x in them on one side of the equation, and the terms that do not have x in them, I'm going to move to the other side of the equation. So here I'm left with 3x natural log 2 minus 2x natural log 3 is equal to natural log 3 plus 2 natural log 2. So now that we have our terms with x on the same side of the equation, we can come in and factor that x out. I'm going ahead and writing down what we are left with after we factor x out from the side of the equation that we put all the x terms out. And once we factor that x out, we're almost done, because all we have to do to solve for x after that point is divide by everything that we have on the inside of the parentheses. So for instance, if you choose to use log base 2 as your logarithm, then that would be our answer there. On the other hand, if we had chosen to use natural log as our logarithm, then this would be our answer here. So although these answers look quite different, they're actually the exact same thing, and either one would be perfectly fine. Maybe you think the one on the left is a little bit easier because we do have this canceling out right here, and you see there's no log on the left side of the equation anymore, but that's just up to you.